species, and they will tell us a little bit about them. I have to say goodbye to the ambassador. I'm going down to give him a visit card of mine, so it will take me a few minutes. Sean could start in the meantime. Because we are in a hurry, we have to go to the restaurant. I will call that in the restaurant that we're coming a few minutes later before they give the dishes away. And so it won't be a problem. So if you don't mind to start, I'm going down and check the things with the politicians. So thank you. How are you? Cheers, sir. Okay.
Thank you. Well, it's a real honor for me to be here. Thank you for inviting me. My name is Sean Goodchild. I have worked with the federal government in the United States for a dozen years with native fish in Nevada. And we work with imperiled fish, so it's mostly pupfish, but also we have two species of Goodchild I work with. This presentation is an overview of the three species of Goodchild that currently live in Nevada and the United States. There used to be four, one went extinct, but we still currently have three. My background was management of the species in the wild, and I'm not too familiar with the aquarium side of the species maintenance, but my expertise has to deal with habitat restoration and other activities which are intended to preserve the species in the wild. And this presentation gives an overview of some of the stuff that I've done. This picture is a spring in central Nevada. I chose it because it kind of encompasses a lot of the problems that the Goodchild have in Nevada. As you can see, the banks of the spring are really incised. There's a lot of public activity, and actually people come into the spring and play basketball. So there's a lot of disturbance, a lot of disruption of the spring, which caused that incision. You could also see it, there's a lot of grazing, so there's cattle out there, and there's also industry. So there's industry, and there's also population growth, there's groundwater extraction, and just like in Mexico, we're losing a lot of our springs are drying up. Now this is one of the springs that we did restoration on. This is a Big Springs on the Duckwater Indian Reservation. And we brought in heavy equipment, filled in a lot of the sides, made it erosion barriers, and now it's like a really nice habitat for river valley spring fish. So I come to Europe and talk about Goodchild, and the first thing I put up is a Phanius and a mosquito fish. And this is to illustrate that we all have the same problems. It's a global issue. And if you look through some of the work in Spain, it's pretty much exactly what they do for a Phanius is what we do for Goodchild in the U.S., but it's independent. There's not much communication between the U.S. and even the United States and Mexico. But really the problems are universal that we have. It's groundwater extraction, there's habitat destruction, there's invasive species or alien species such as the mosquito fish. And there's so much similarity in our issues, and I think meetings such as this really help facilitate communication to solve those problems. Where really you look at borders, national borders, there I'll move into an introduction to what we have. We have two genera of amphibians, the Crenectes, which is a spring fish, and the Amphictytes, which is a pool fish. And both of them live in kind of these systems where there's a spring pool and an outflow from the spring pool. Pretty much all the spring pools, such as this one, you can see there's a dam right there, have some sort of human modification, mostly for irrigation. For example, this diverts water down a ditch which goes this way, and the normal spring outflow, which normally went back in here, is highly damaged because of that. But this seems to be really good habitat for the spring fish, and there's a lot in there, and they also occur somewhat in the outflow, but really the temperature is a bit screwed up because of the human activity, and there's really not as much as it could be. And there's also, you get outflows like this, there's a lot of alien species such as red swamp crayfish and Bacillus mexicana, which we'll get to later. The fish I'm working on now, I left the federal government, and at North Dakota State University, I'm working with the pool fish. Beyond work that's been done at the University of Nevada, Las Vegas, we're really the first people to really keep pool fish and figure out which makes them tick. And we're partnering with a aquarist who's really looking at the reproduction end and how to keep them in an aquaria, whereas I'm looking at life history work and see if fish in different refuges where they're placed turn into different fish. If the fat content is different, the ovary size, and other issues. I'm also looking at parasitology, and we're looking at community ecology with to see if we could recreate a historic population structure that we saw with the extinct Amphictytes, which is ash meadows. So an overview of Nevada. Nevada is in the southwestern United States. The Goodchild, the Amphictytes occur in this area of Nevada, and the springfish, the Crenectes, occur in this river system, the White River system. It's a very arid state. It's pretty much all desert except for some up in the mountains. It's there's a very low population. It's similar to Russia, very sparse. Very few people living there. Pretty much everybody lives in Las Vegas, which is right here, and Reno, which is right there, which causes its own problems. We'll get to that. There are many springs in Nevada, and they're fed by this deep carbonate aquifer. The aquifer originates up in this area, and by the time it flows down to the southwest, and by the time it reaches the end down here, it's approximately 10,000-year-old water. It's a very ancient and very vast water system underground. Again, I put the stars for reference. This is the White River system where there's spring fish. This is where there's Amphictytes. The water is geothermically heated, so it's all warm springs that come up. There's a few cooler springs, which are basin fill aquifers. Basically, it rains in the mountains and comes up in the valleys, but for the most part, it's really warm water. This photo here is was taken probably around down in this area. It's the lowest, southernmost location where the springfish occur, and it's a highly endangered ecosystem. There's a couple of the Chronichthys bailey-eye, the white river springfish, the Moapa subspecies. So this is a highly endangered minnow. There's less than 1,000. Well, I think the last count there was a little bit over 1,000 individuals. It's a Moapa dace, Moapa coryciae. Most of the management in this area down here is for that fish because it's an endangered fish, and some money gets allocated because it's endangered. But the springfish benefit from that. This springfish actually has no federal protection or state protection, so you can't get funding for that. But since this is endangered, we do a lot of habitat work there, and the springfish really benefit. In these systems, there's also a lot of other endemic species. For example, you can see these little green blobs. Those are an endemic spring snail. It's a Pyrgolopsis, and they only occur in this one area where the springfish occurs. Throughout Nevada, there's a lot of isolated springs, and they each have their own species of spring snail. There's also a lot of other aquatic invertebrates that occur that are endemic. So really, if you protect one fish like this, you're protecting a big suite of individual species that have evolved specifically with the bullfish or the springfish. What happened in Nevada, you wonder why there's so many isolated springs. This is normally what Nevada looks like. This is like 99.9% of Nevada. But if you look at the habitat 10,000 years ago, there was these large Pleistocene lakes that occurred. This is the Death Valley area in California. You see the gray areas used to be very large lakes, like 8,000 years ago. Over that period since the Pleistocene, which we call the pluvial period, there's a lot of water. The climate is dried, and there's not as much rainfall. So these lakes gradually dried up. All the streams that connected these lakes, there used to be rivers, they all dried up, and naturally, due to desertification. So the only water that's left are these small little spring-fed parts of those lakes. So what happened was the fish, the ancestral species probably occurred all throughout here. There's probably a lot of different species as far as we know. But as the lakes dried, they became increasingly isolated and diversified from there, or not diversified, but evolved. So each of these little springs, pretend this is Nevada, not Death Valley, would have its own species or subspecies of fish, or for the most part, aquatic invertebrates. That's the hotbed of what diverged. So as the population increases in Nevada, we have all these little springs that are isolated. There's a lot of demand for water. There's, especially the Las Vegas area, people like their lawns, their grass in Las Vegas. They have golf courses, casinos. It's a lot of demand for water. There's still a lot of agriculture in Nevada that uses a lot of groundwater, and and that really increases the demand on the system. And we're losing, we think we're losing a lot of our springs because of that. In the past, we have is unregulated, so people would dig a well right by the spring. Where do you go for water? Like the most reliable water, put a well right on the spring head. So historically, we lost a lot of springs because of that, but just getting better was better laws. We're going to hear more about this, but I just wanted to put this up to show you how the United States Goodeids kind of fell out. We had the Chronicthes and the Epitricthes that diverged, sometime in the Miocene, and diverged from the Goodeids probably 17 million years ago, or the rest of the Goodeids. They're very, very closely related to Pteranodon, or I don't know if that's the right word, closely related, but they're very similar. But they're just kind of this weird outgroup that diverged quite long ago. And that was at some time the Colorado River used to flow into the Pacific near Los Angeles. And I think sometime around then is when they're isolated from the rest of the Goodeids. The difference in the U.S. Goodeids versus the Mexican Goodeids. I conveniently stole this picture off the internet, so, but I thought it is quite nice. The Mexican Goodeids have the split fin since they're live bearers. The U.S. Goodeids don't. The pelvic fins. I don't know, you guys could probably answer that if all Mexican Goodeids have pelvic fins. They do, so that's a difference. But they're still very similar. They have that kind of the anal fin and dorsal fin way back on the body, which in a way kind of reminds me of a northern pike or something, but they're quite different fish. We'll start with the Chronicthes. There's two species of Chronicthes. The Nevadae, which is the Railroad Valley springfish, and the Baileyii, which is the White River springfish. There's many subspecies of Baileyii, and this is kind of the range that they occur. This is the White River Valley, as I showed you before. This is where Las Vegas is, in the Colorado River. And there's 5 subspecies of Baileyii. The Nevadae, the Railroad Valley sunfish, the springfish occurs in an isolated valley here, but all the other ones are kind of in these relic springs that used to occur in the fluvial White River. So you could imagine at one time, 10,000 years ago, 8,000 years ago, when the White River was flowing, there's probably some kind of springfish all throughout there, or there's at least some kind of connectivity. But since it has dried and the remaining water has really cooled off, they become isolated in these spots. And I'll quickly go through the individual fish and show some pictures of the fish in the habitat. A lot of these pictures of fish came from Kevin Guadalupe, who was in the Nevada Department of Wildlife, and a lot of them came from me. For example, I took that one. But the Railroad Valley springfish, it seems to be like a little oranger. They have that lateral stripe. They seem to me they have the darker fins, and they're really beautiful fish. There's a lot of weird fish. I think this one's injured. at one time, so its tail grew in kind of funny. But you find a lot of that in some of these springs. There's a lot of kind of misshapen fish, and I think part of it, they live in poor habitat, so to speak, really hot water, not much oxygen. So it's probably a stressful habitat for them, and they're probably at the limit of their range of what they can handle. So you can see this one has been fin clipped, and what they do is clip the lower fin for a mark recapture estimate, come back later, and then you could tell the portion of the clip fins versus the non-clip fins and get a population estimate of how many are in the spring. And that tail fin grows back really fast, probably within 3 weeks, so you gotta be really quick with that. So the habitat the Railroad Valley springfish live in is there's very few trees. It's a very kind of sparsely vegetated valley, but it's really swampy, and there's a lot of carex and sedges, and a few spots of standing water like this. There's a lot of habitats, such as up here, that are just way too hot for the fish, and this one, the spring right here is 71 degrees Celsius, and they actually had to fence it off because people would come out and their dogs would jump in the water and die, so they had to fence it off just for safety. But the water is just blazing hot there, and as it cools off, then you'll start picking up spring fish down here. You'll find some occasionally up in here. They just swim in and out, and you could set a minnow trap in here, you'll catch some, but the temperature might fluctuate up enough that they'll all die in the trap. So, but they spend a little time in the hot water, probably forage a little bit, and then go back down to the cooler water for a thermal refuge. In places like this, there's really high densities of the spring fish, and there's several pools like this in the valley with a lot of fish. This is a really isolated valley. There's one road going through it, one main road, and really not many people know about it or go there. There's water extraction from there. There's oil production. So there's a few threats that might occur here. But as far as I know, there's no invasive species, no alien species here. And really not much habitat disturbance other than what you see here, where people would dig out and sit in the hot spring. Nearby, in that first picture I showed as my title slide, there is a large spring complex where we've done restoration that also has Railroad Valley springfish in it. There is invasive species in there. There's Tilapia zillii, there was Gambusia finis, and I think Posilia mexicana, the short fin line. And we did a road known to remove the tilapia. We removed all the tilapia, but failed to remove the Posilias. But the springfish are doing really well in there too. This is my picture of a Preston White River springfish, meaning I don't have one. The people that are going to send me one, I've never been to this habitat, but it's kind of up out in there's a lot of private government partnerships to restore some of this habitat. This is similar to what you'll see that has springfish there. This picture is actually at Ash Meadows. It's kind of the opposite side of the state from there, but it kind of gives you an idea of the habitat that occurs there. The problems here is that there's a lot of groundwater extraction. There's a lot of habitat disturbance with cattle. So there's a lot of vegetation that grows in the stream and kind of chokes it out, and that kind of makes springfish really kind of rare in these systems. So it's kind of neat. A lot of private landowners are partnering to restore the springs on their property and come up with ways to allow like livestock and the fish to coexist. Cattle and the horses. And Mormon Spring springfish. This is another fish that I wish I had a picture of because, in my opinion, they're the brightest springfish. They're just a beautiful fish. And I have some pictures that I took before I had a digital camera, but I couldn't find them. But they occur often kind of an isolated spring also in central Nevada. This is a picture of the Hot Creek where they occur, and there's several small pools and several outflows that they're quite abundant. There's a lot of these fish here. I think the last survey was 10,000 of these fish in the spring. There's one spring, well, you can see the pipe there, and that's part of the problem. It's, the pipe takes water to like a cattle trough down there, but it's better than having cattle in the spring. But there's one spring that's very deep, and it's a very beautiful spring. It's probably 10 meters deep, and that has the springfish in it, but there's also largemouth bass. So the springfish are really are actually kind of rare in that habitat because the bass eat them. The Hyco White River springfish, it occurs in two springs. The Hyco Spring and Crystal Spring, and they're southern. They're kind of in the middle of the White River system. If you look at the distribution of springfish, they're very variable, and I think this is true as most springfish. These are all Hyco. Some of them have the dorsal stripes, kind of the typical springfish you'd see. There's some that are just kind of all tan color with very orange fins. And my friend took this picture not too long ago of an orange one that he captured. There's another one that we clipped the tail to do a population estimate. These occur in two springs, native, and but also we have a pond that was built called Blue Link Spring that has a refuge population of this species. So there's three locations that this fish occurs in, but all three of them really are poor habitat, I think, and I think we could lose some of these fish if something goes wrong with that habitat. These also occur with convict cichlids, an invasive convict cichlid that were released because of aquariums. And there's also shark fin mollies and red swamp crayfish. Probably have a big impact on these guys. here's some of the habitats that they occur in. This is the blue link spring that I was telling you about. This is this used to be a seep that probably in the 1950s somebody stuck a bunch of dynamite in it and just blew a big hole out, for the cattle. And then they put a little dam here and made a spring. And it turns out to be perfect for spring fish. So there's a population of spring fish. It's very remote. You got to drive probably an hour on a really bad dirt road to get to it. So nobody goes up there. But this dam is failing here, so I'm not too confident of the long-term maintenance of the species in here unless there's some work done. It's also being filled in with sediment, and so that's a problem with a lot of these new artificial habitats that are built. They just aren't good self-maintaining systems. Here's the slide again, or picture again. This is Crystal Springs. This is that water control structure. There's quite a few spring fish in here. The spring comes in from down here. It's a fairly high flow spring, and it's really good habitat for these fish. If it wasn't for the convict cichlids and the crayfish that also occur in there. Right across the valley, we have the Chronichthys bailey, which is the nominal White River springfish. In my opinion, this is probably the same fish as the hyco, and it was separated out because of morphometrics. The finnage or the scales were a little different. Some of the measurements were a little different. But if you look back at probably 50 to 75 years ago, they were probably connected by a stream. But since then, that stream has been lost. It got turned into ditches, and now it's cold water, and it irrigates fields, flood irrigates, so it's just not suitable for spring fish. But to me, I bet this is the same species or same subspecies, and I believe genetic work is being done on that to resolve that. Bernie Maid and Gary Scapitoni out of Davis has worked on that. They occur in a spring that is very highly modified. A lot of people swim in it, and you go in during a hot day. There's could be 100 people in this area just trampling all the vegetation and the gravel. But so you find very few spring fish in here. You see a few, but where you go down below where people don't go, this is private property back here. There's quite a few, and there you'll see all the algae and the aquatic vegetation that they'll occur in. Trying to think of the name. The watercress. There's a lot of watercress that support the fry. So they do quite well down there, but where people are disturbing it, there's not many fish. This is kind of the headwaters of the spring.
What are the traps for? On the underwater foto, there are some traps.
The what?
There are some minnow traps or crayfish traps on the underwater photo. What are those used for?
Oh, there. Yes. Yes, this is an underwater photo I took of the spring. We were trapping, we're doing a population estimate of that, and I just got in the water and I took a picture. So that's where we get catch the spring mark their tail and run the ratio and see, get an estimate of how many fish are in the spring. We also remove crayfish. Using that, we throw in a bunch of traps, and usually they have a little wider hole where the fish could go in and out, but the crayfish come in and they can't get out. So just try to cut down the number of crayfish. You can see like people have been walking around in here. It's all sand on the bottom, no vegetation, and there's also a red Luigia, the aquarium plant that's non-native, but and it's been established in the system. This is the only place where I've seen it in Nevada, but the spring fish seem to really like it. It seems to be beneficial. The springs are crystal clear. It's just beautiful snorkeling through some of these, and it's like swimming in an aquarium. So the southernmost spring fish is the Moapa White River springfish. I showed a picture of that earlier. Was the Moapa days. It occurs in the spring heads and outflows. And these are all restored outflows. They're man-made, but we think that simulated what used to be there over 100 years ago before it was disturbed by humans. There's a lot of these spring fish in the valley, but you can see they're all isolated by desert. These are non-native palm trees, and but it's quite a beautiful area. So this slide's kind of out of place, but I wanted to show you a stream viewing area, a stream viewing chamber that we built, and this is a stream that we restored that has the Moapa White River springfish in it. For this restoration project, we had funding to add a public component to get public education into it. So what we wanted to do is people could come in here and they could look through the window here and see the fish. And this is right after it's built, and we put the stream through. But now there's benches, there's a sunshade. It's really nice. And we actually have springfish and Moapa dace in here. So I wanted to show you that real quick before I videos never work for me. It's not working. Oh, yeah. Well, actually it's in there. I'll just show it later. So, I had a little video that I took through the window of that chamber, and it shows some springfish swimming around, and it's kind of neat because they're actually in the flow of the river. They are in the spring, so to speak, and they're using rocks as microhabitat, and they go and hide behind the rock and come out and grab food, but they're in that little eddy behind the rock where there's not much water flow. So I'll show that later. Yeah, we're running out of time. So the other genus of fish of Goodchild in Nevada is Impetructes, the pahrump bullfish. This is a monster fish. This is the biggest one I've ever seen. It's probably 8 centimeters, so big fish, and it's pretty much the biggest they get. This is probably I bet you this is a 4-year-old female, just from what I've been dissecting, and I've only found them up to 3 years, and that's really a big fish, the 3-year-olds, but I bet you this one's older. So there's 2 species of Nymphotrichthes that used to occur in Nevada. One, the Merriamai has went extinct. That occurred in ash meadows. The Latos, there was 3 subspecies of Latos. Two of those went extinct. The third one was extirpated from its habitat in the wild, but prior to that, it was a few were captured, brought into captivity, and then they're moved out to different refuges. And I'll have pictures of those. There's Las Vegas in reference. So this Google Earth picture shows the historic locations of these poolfish. Las Vegas is down in this area, but there used to be a large valley, and there was several springs in here that all flowed out in this direction, and that's where the Latos occurred. This is Ash Meadows National Wildlife Refuge, which is a large spring complex. It's a biodiversity hotspot, and it's been actually hypothesized that you could that Charles Darwin could have went there and wrote the origin of species there, with the instead of the finches. But there's many springs here. They're all isolated by saline soil, and there's at least 25 endemic species that occur there. There's probably more if we looked at the more invertebrates. But this is where the Nymphotrichthes merriamai occurred. It went extinct in the 50s. These are the historic locations, or the prehistoric locations that probably connected these fish. There was stream flow through here, which connected in here, and went down to the Amargosa River, which eventually flowed into the Colorado system. In this area, in the past several thousand years, one of the mountains eroded and it filled up with rocks, so that separated these 2 valleys. So that's where these two species of Nymphotrichthes diverge. The merriamai occurred at Ash Meadows. It is now extinct. It occurred in, as far as we know, in only one spring, the Big Spring system. This is a fairly deep spring. It's probably I don't know. It's probably 10 meters deep or so. It's a fairly large spring that has been ditched, just turned into. They ditched the water out here for irrigation. This is right after a fire, so I thought this showed the system fairly well. And this is also a very highly modified system. Pretty much anybody went to this spring back in the 60s and 50s, even the 70s. And there's actually, over in this area, there's several brothels. So people would go down to the spring and hang out and cause a lot of damage. This is the underwater picture of that same spring. This is like like a spring wall. You can see how steep it is, and that's from all the human disturbance. The substrate of the spring is all this spirogyra, the filamentous green algae. These are all pupfish, mostly Cyprinodon evidensis, Myanectes, and there's also sailfin mollies that occur in there, quite a few. Oh, most of the fish in there are sailfin mollies. There's also mosquito fish, and currently there's a few largemouth bass in there. But habitat restoration we do. I got a better slide of it, but essentially we construct a habitat from new, just from scratch, and just estimate what the geomorphology of the area used to be and what we thought the spring and the outflow looked like, and go from there. Alien species removal. These are the 5 top 10 that we work with. The blue tilapia, mosquito fish. This is a red swamp crayfish, which is causing problems here in Europe. The springfish are co-occur with the convex cichlids and the short fin molly, which are both we believe were released by Aquarius at one time. These convex cichlids, you can't keep them from breeding, so we assume somebody had a tank full of them and didn't know what to do, so they go and dump them in the spring. They don't want to kill them. So we do physical removal. This is an example of a crayfish trap that we use, electrofishing. We've tried sterilizing crayfish and releasing them. That doesn't work, or it'll probably work if we do a lot more effort. Trying all kinds of things. We also, this is from one of our electrofishing expeditions, actually from that one. That's a barge. There's a generator on the barge, and we run electricity through the water, and it rolls everything, and we get out what we can. We do habitat manipulation to make it unsuitable for alien species. This is an example. There used to be a sheet flow of water coming down this direction, and it's just full of mollies, mosquito fish, and it was ideal habitat for them, but not for the spring fish. This is at Moapa. We put a sandbag barrier, and now it's like a stream channel, and it's loaded with Moapa days, and there's some spring fish in there. It's a little too fast, but there's no non-native fish in there. We manipulated the habitat to exclude the invasives. Here's another little spring that we built. We put this pipe here, and there's like a little waterfall right there, and that keeps the mollies, the short fin molly, from getting up in here. And the spring just only has spring fish in it, the Moapa White River springfish, and they're doing quite well in here. No mollies. There's a lot of mollies down in this area. But little things like this could really make a difference in your restoration. But then again, this isn't permanent. This is going to last a few years. This has already failed. So these are only band-aid approaches that you could do to manage them. Then we have the nuclear bomb. This is we do quite a bit of rotenone projects, which is a chemical that kills everything with gills, very much. It doesn't kill everything with gills, of course. Red swap crayfish don't die from retinue. And whatever you want to kill, is hard to kill, but what you don't want to kill is easy to kill. So we've been, you could drip it down into streams or to larger ponds. We use the boat. And then we detoxify the water so it doesn't go downstream and cause more damage. Of course, the natives are the first one to go, so we try to salvage as many native fish as we can before you treat with rodent. And then what you could do is keep them, and after several days, reintroduce them back into the water, and they'll be fine. This is a bunch of blue tilapia we got out of an area with Malacca White River springfish. As one of our unsuccessful tilapia treatments, we found tilapia several months after we treated, so we think some got missed. But this is quite a beautiful short fin molly. They're a really beautiful fish, I think, but in a bad system. The habitat restoration, there's a lot of major problems with invasive species, invasive plants, and disturbance of habitat. For example, with the Malacca White River springfish, we have invasive palm trees that are non-native to the area, and they were planted 100 years ago. And this is the perfect environment for them, so they just grow up like crazy. And what they do is they create the roots fill in and they create ponds, and there's 100% canopy, so there's no sunlight getting to the stream. So essentially, these ponds are sterile. There's nothing in them. It gets a lot of debris in the stream. You can see there's a stream coming right through here, but you can't really see it because there's just too much palm fronds. And then lightning will hit them or something, and you'll get a fire, and everything in the stream will get killed. The heat from the palm fronds will sterilize the stream, and the ash will cause a pH shock, and essentially there's nothing alive in the stream anymore. And it has to be seeded from upstream where the fire didn't hit, or if we're lucky there's fish up there, but these palms are really causing a problem. And that's the tip of the iceberg of what the problems that the palms cause. There's a lot of other issues that occur, but one of the goals of the restorations are to remove the palms and to create better habitat for the springfish. So typically you go in and you cut down the palm trees. They're really difficult to cut down, and we found it's easier just to push them over, dig around and then push them over, but it's a learning process. And once you get this bare area, you just dig a channel through it, and you got your instant stream. Put some rocks in it and some logs, and the springfish do pretty good. This is the final product of one of the streams we built. Again, I put this in, we put a public component. There's a lot of trails along here, so people could come and look at the fish and learn about the fish, and just kind of spend the day there picnic. But this is really good springfish habitat. You find tons of springfish in there, and also around in where the riffle comes into the pool, there will be a lot of the endangered Malacca days. All the other endemic invertebrates are in there too, the snails, and So here's another picture of that stock pond, which is in Patrick's Refuge. This is kind of the nightfall of my last trip in August, where I collected some fish, and I'm in the process of dissecting them now, just to learn more about their life history. But with that, I'll entertain questions, and feel free to contact me anytime, email, and I forgot to put my email address here, but I could be a resource. I'm a student of these fish. I'm not an expert. I've been working with them for 12 years, and you still learn something every day about them. So I'm eager to start a dialogue and to learn more about them, and so I'm available. So thank you very much for your attention.
So your email is?
Pardon?
I want to take a note of your email.
Email.
Yes.
Okay. It's ACHIRUS, which is a flounder. Achirus.
Yes.
At Earthlink, LINK.net, and that's my home email address. So I should have that forever, hopefully, unless I lose my home.
Thank you.